everyone, and good afternoon. Welcome to the ntop Spring webinar. Today we'll be talking about a few things. Unfortunately, we don't have a lot of time, so therefore we'll go very quickly, and we'll try to share some slides and some information after this webinar on our blog. The first topic will be the ntop cloud. That is an ongoing activity I will be describing first. Then we'll be talking about artificial intelligence and large language models, what we are doing in ntop and how we plan to use them in future products. Then we'll be talking about the SmartNICs. In particular, we'll be talking about a new product called ntop that will be introduced today. Finally, we describe some news about the ntopng developments, in particular for companies that have many devices and a lot of traffic. And then at the end, we'll have the question and answer session. Before we start, I would like to remind you that for those who are interested in having access to the professional training, that the training will start soon, in about a couple of weeks. You can read more on our website. The training will be available through Teams, so therefore people can join wherever they are. And every session will last 1.5 hours. For those who instead are planning to travel to Munich in June for the CheckMK conference, we also have the ability of meeting in person at the CheckMK conference. This will happen on July 13th, when we'll have a workshop about ntopng and the integration with CheckMK. We don't have many seats left, so if you are interested, please rush up. Before starting, I also want to remind you that you can read about the latest news about ntop on our blog, blog.ntop.org, and that you can join at any time our community servers on Discord and Telegram. And this is a good way of interacting, and it allows you to be notified immediately whenever there is something new or to get in touch with the developers. Okay, let's start with the ntop cloud.
Sorry, Luca, I cannot see your screen.
Okay, let me try again. Can you see the screen now?
No.
Okay, so it is shared. Let me try again. Okay, what about now?
Yeah, you can see that.
That's better now. Okay. Okay, the first topic will be the ntop cloud. So the goal of the ntop cloud is not to create a software as a service. This can probably be a future goal, but the first goal is to try to create an infrastructure that allows applications to be located, regardless of their location. So it means that if you start ntopng on a laptop, nprobe behind a firewall, and N2Disk in a data center, as of today, they are unable to talk unless you have a VPN. And this is probably a problem. The second point is that we want to allow you to supervise and to update those instances from a single point. That can either be a web console or one ntop application. And this has to be done per user. So it means that we don't want to mix traffic information across users. Everything must be privacy protected. Communication must be private and encrypted, so there is no way to communicate in clear text. And this is paving the way to new developments that we have in mind that allows us to create and integrate applications together. So the first integration will be shown today. This is a work in progress, as I've said, and we have many plans. So I'm going to show you now what we have ready today. The idea is to consolidate this this year. So by the end of the year to have something stable. At the moment, everything is in beta. All the ntop application will support it. At the moment, we support only nprobe and ntopng, but soon we'll add support for all the others. And this is an ongoing development, and all the things I'm going to show you today are available on the dev branch. We plan to have a next stable release in June, July timeframe that will add initial cloud support. So it means that the application will be able to talk with the cloud and interact with the cloud. As I've said, we are rolling out features over time because many things have to be modified under the hood, and we want to make sure that everything is working well. As of today, The cloud is in beta stage, so it means that you can play with it, you can interact with it. It is probably going to change over time. Change mean add new features, add new things that are beneficial for our users. And we plan to have it in stable, so official release with the follow stable release. So it means not in June, July, but in early next year. Let's see how it works. I'm going to show you some screenshots, and later.
Sorry, Luca.
Yes.
Luca, we still see the goals slide. Yeah, now we can see the auto enroll.
Okay, I'll leave it as it is. So the first thing you have to do is you have to connect to cloud.ntop.org and register for an account. So in essence, you have to enter your email address and a password. The registration requires very limited authentication. So in essence, we ask you who you are, and as soon as you have registered, you will receive an email. The email is what we need to authenticate you, to make sure that the email address corresponds to you. Then on this email, you have a link. You click on deactivate your account, and then basically the account is created. So this means that you can now access the GUI of the cloud. So the first thing you have to do, of course, a login. But when you log in, okay, we need a third element. So in essence, we have to implement a one-time password. One-time password requires you to configure a one-time password application, such as Google Authenticator or the Microsoft Authenticator. So in order to do that, you have to click on request and enable OTP, okay? So under the confirm code button. This will send you another email that allows you to configure, simply clicking on the link, your authenticator. From this time, you have the authenticator configured as with many other websites, and then you can verify your account and log in to the console, okay? So this is the web console. Everything is protected. So it means that we cannot disable OTP, we cannot disable login, so everything is completely protected. And as I've said, the two-factor authentication is a process that you have to do once, only the first time. So only the first time that you connect to the cloud, you have to configure your authenticator. Done that, you're basically ready, and you are ready to use the cloud console. I'm going to show you a demo in a second. I just want you to focus on the process. Now, once you are connected to cloud.ntop.org, the only thing you have to do is that you have to download something we call cloud.conf. The cloud.conf is a file that you have to deploy under /etc/ntop of your machines, and that will be used by the ntop application running on that machine to connect to the cloud, in essence, without adding credentials. This file is encrypted. It contains your credentials. In particular, this file does not allow us to see your credential, because when you create your account, the couple private and public key are created inside the browser, and only the public key is sent to the ntop cloud. So it means that the private key will stay local on your machine, okay, in an encrypted file. So in essence, the browser is doing everything. In other words, ntop does not have your credential. So it means that you can access your data, but we cannot access your data. And even if by chance, other people would like to access your account, even though they can violate the system, we hope not, but supposing this is possible, they are unable to see the data or your data simply because the traffic is encrypted. I will talk about that in a second. So in essence, the first time you have to download this cloud.conf and copy it under /etc/ntop. That's all. This has to be done on all the machines where you have deployed the ntop software. Done that, you simply restart the application. The application will be immediately available to the cloud. So in essence, it's a quick configuration. Connect for the first time to cloud.ntop.org, do the registration, download the cloud.conf, and restart your application. That's all. Now, what we can do with the cloud? With the cloud is a dashboard. As I said, I'm going to show you a quick demo soon, that allows you to see your applications that all talking with the cloud. Okay, the application don't send data to the cloud, but the cloud, it is used as a network overlay to allow application to communicate and to talk each other. You can see all your active instances. You can see the traffic of the instance when the application has been started. You can see the version. You can immediately click on application and perform actions such as update the application. So you simply click on a button at the bottom of the screen and tell the application that you want to update it, or you can restart the application, typical things that you usually do from the console. Instead, you do it from a web GUI. And of course, you can access your licenses. So it means that one of the features that many people have asked us, so to have an overview of their licenses to see who's using them or if some licenses are expired, it is finally now available because you can see everything from a single page that allows you to do exactly that. And from the same page, you can also click under the order ID column, access your order ID. So you can see the license when it was generated, if a certain license has been revoked, usual things that you do now more manually, they will be automated. Now, under the hood, we have decided to be super secure, as much as possible. And we do this through a double encryption. So every communication is TLS encrypted, TLS 1.3. And this means that we guarantee that the data from your application to the ntop cloud is safe. But in addition to that, as I've said before, we encrypt the data with the state-of-the-art ES256 that allows the messages to be sent and received only by a certain recipient and encrypted with a private to public key. That is the same security feature that is used by other security tools or VPNs, such as WireGuard. So this guarantees us that even though somebody is intercepting your traffic, is able to violate TLS, they are unable to decode the traffic. And this also guarantees that user Luca will be able to speak only with user Luca. I won't be able to talk with other users, okay? Simply because the data that the other user will receive will be encrypted. So it means that it's not possible. And we guarantee that the platform prevents two users to communicating directly. So the first principle is user fencing. So we want to avoid that. The second principle is that encryption keys are generated on your browser. So it means that they are never shared with ntop or with anybody. So you have to keep them, private on your system. The problem and the drawback of this solution that is used by many others, such as, for instance, WhatsApp, when you send this data, is that we have no way to decode your traffic or to access your data. So it means that if you lose your credentials, you have to register again with the same process, and you have to redeploy the cloud.conf. Okay, this is the only drawback. Now, once we have done that, so we have a network overlay that allows us to communicate. So it simplifies many things that we wanted to do for a long time in a more complex way. So for instance, the cloud licenses. With cloud licenses, we overcome the limitation of traditional licenses that are bound to a CPU and a network adapter. With cloud licenses, it's possible for us to give you a license that you put on a machine, okay? And this license can be used on other machines regardless of the system that is currently using the software. And with this license, you can simply validate the license with the cloud in a very simple way. I will show you in a second. That allows you to basically to unlink, okay, the application from the hardware. So it means you can have ntopng running today on one machine, tomorrow on another machine. Of course, not simultaneously, but one after the other. So this should dramatically simplify the system and also opens new things such as the possibility of creating a per service license. At the moment, these licenses are in beta. So it means that as of today, you can choose when you generate the license, whether you want to create a standard license or a cloud license. The standard license does not require internet access as of today. So it allows you to run the application on a standalone machine disconnected from the internet. The cloud license requires cloud access. So it means that if you have to configure ntop cloud first, and then once you have your license installed, the license will be validated. The validation process is very simple. When the application starts up, basically reads the license file that is either missing or not good for your system because it was created on another machine, and then it detects that and it tries to connect to the cloud. Goes to the cloud and says, this is my license, so what shall I do? And the cloud is validating the license and reporting that the license is fine. So therefore, the application can continue. And the validation is a process that continues over time. So from time to time, you can check that. So it means that you can move your instance from one machine to the other using the same license without having a license that, as of today, is bound to a specific hardware. What is missing? Many things are missing. At the moment, we just have a cloud support in a few applications, and mostly in ntopng, nprobe, and IPT geofence. And we plan to add many new features. For instance, the ability of informing users when something has changed or when an application is unavailable, or for instance, receive an email, okay, when this happens. In the future, we'll be also implementing a remote procedure call, so it allows application to communicate. So for instance, when you have, let's say, a probe that is talking with ntopng and sending data to it, so in case you want to see the configuration or modify the configuration of mprobe from ntopng, you can simply apply it and restart it from the ntopng without going to the shell of mprobe. We also want to send the telemetry to ntop, okay, with prior consent, of course, so that we can monitor the application and try to figure out if there's a situation where our applications are not working properly. And in case of crash, be notified and try to improve the application and support it. And one of the first things that we'll be introducing will be the support of blacklist. As of today, ntopng is using blacklists that are downloaded periodically, usually once a day. While this is good, it is not perfect because for blacklists, we would like to be notified immediately. So this could be a good way of sharing this data across application, either from the same user. So suppose that you have a company with you have many deployments, and suppose that the branch A is under attack by a certain IP, you want to notify all the other applications of your company to restrict access to such IP, because such IP has attacked the one branch, it probably will be attacking other branches. And another feature is that we want to inform instances about the changes in configuration and deployment, that this can be very well used for future applications to simplify the way they're working. Now I'm going to show you a very quick demo because, as I said, unfortunately, we don't have too much time today. Okay, so this is the ntop cloud. As I've said, you have to connect to cloud.ntop.org, and after the login, you're inside this web view that, as I've said, will be modifying over time. There are a few menu items on the left side. Okay, the first menu item allows you to supervise all the instances that are running. So you see here we report the total amount of traffic, total amount of flows that are monitored by your applications. The tab below allows you to configure your application. Simply, you can download the cloud.conf file, and you can install it, as I've said, under /etc, and then restart your application, such as ntopng. Here you have the list of active instances. So for every instance, you can see where the instance is located. Okay, what is the application? This is the traffic, and you can see the version and when it was started. You can execute some actions, such as, for instance, you can click on one instance and say, update. Okay, you can restart it. Okay, this means that from the cloud, we send a secure message to the remote application, executing that. So you don't have to click as it is today on individual application and go inside ntopng or from the shell to update instances. And this allows you also to see whether you have some problems, whether some applications are not running well, so they are restarted. At the same time, you have the final tab that allows you to see, for instance, your licenses. These are all the licenses that are registered on your application. So for instance, you can click on one of those. You can immediately jump to the licensing page. You can see, the license, when it was started, the maintenance, the generation date, and everything. So this from a single page. As I've said, we are improving it, so it's not ready for everybody, but it is enough today for application to communicate. It is enough for you for clicking and started for doing, this type of things. I thank you very much for your time. So we now need to move to the second slide deck that is about large language models. Okay, Gabriele, if you want, you can start your screen. The large language model is an activity, mostly research activity that we are doing here at ntop, and it is not consolidated, so it's something ongoing. And I'll let you, Gabriele, talk about that. Thank you very much. The Q&A will be at the end.
Hello, everyone. I'm Gabriele. Can you see my slides?
Yes, Gabriele.
Yes.
Okay, so today I will show you a recent integration of large language models inside ntopng. And as a disclaimer, I want to say that this is just a proof of concept as of now, because things are changing very fastly in the large language model space. So we are studying some possible integrations of large language models inside ntopng. So we wanted to see if large language models or LLMs can be used inside ntop because of the increasing number of threads and connected devices to a network. This is because with the increase of devices in a network, there is a high possibility that more alerts are generated, and we want to automate this alerts analysis task. And also because there is a high cost to keep a security operation center running, and we would also like to automate this task. And also because LLMs can be used to emulate a real person, as they have human-like reasoning capabilities and can be integrated with agents. So our current solution is a classification-based alerting system that does behavioral checks on flows and hosts, and then produces some alerts that are represented inside a table. So with the sheer volume of host or flows alerts, it's almost impossible to manually analyze all these alerts. And with the increasing number of alerts, relevant ones could be submerged by less relevant alerts, but repeated ones. So we are losing important security inside. And also because there is a delayed response to threats. So I'll just go over large language models. They are a deep learning model used to generate textual data. These models are trained on large text corpus of data, mainly textual data. And when you query a large language model, you use a text question called prompt that is split in chunks and converted to a vector that can be interpreted by the model. And then the response is generated based on the structure of the question and on the parameters inside of the model. Another step is the agent. So what is an agent? It is an autonomous program that receives information from the outside, let's say network alerts in our case. It can decide and have reasoning abilities. So based on the info received, it can select a strategy or how do you want to say it? It can select an action and choose from a set of tools what is the best action at the current iteration. So next you have the action, that is the usage of a function. The function can follow a procedure like a normal programming function, or it can follow a strategy. And then there's also self-learning capabilities like humans do, but we are not quite there inside our implementation. So we combined agents and the large language model to try to see if we could produce reports about the network flow alerts or host problems. We automate these assessments and reports because we want to identify relevant problems, pinpoint it to network analyst or a SOC operation center, so that they can firstly check the bigger problems and then manually check smaller problems that remain inside of the network. And for now, this is just an alternative way to visualize alerts, as instead of a big table, relevant alerts are compacted in a textual report. Right now, we are using a local model to do domain-specific tasks because we saw that some models are very good at networking problems and security problems. They have an outstanding domain knowledge, and then we use the OpenAI API for heavy computation, mainly to decide the steps of the agent and do the reasoning steps, as they are very computational intensive. In the future, we would like to move out from the OpenAI and keep everything in a local model. This to keep alerts locally, to not share it with anybody, and also to have control on the output of the model and maybe even fine-tune it. So give domain-specific knowledge like ntopng alerts or other information about our network, for example, the topology, or if we have configured a backup server that does repeated data transfers should not be considered as a problem because it's expected in this network. And we are also thinking about giving out this product as an on-premise solution, but mainly we want to integrate it inside the cloud that Luca presented before, so that one user can monitor all their instances from one page and compact everything from on a single page application. So doing this, we were able to reduce analysis times by at least 2 orders of magnitude. With this agent and LLM combination, we were able to analyze hundreds of alerts in sub-minute time frames. And if we had done this manually, it would have taken at least 30 to 40 minutes, because one should check every single alert in the table, annotate the source IP, destination IP, and the content of the alert, maybe log it on a textual file or an Excel spreadsheet, and then manually cross-check and do some groupings. So we use an heuristic, and we do this analysis automatically using an agent. Now I'll do a demo. Can you see now?
Yes.
Okay, so inside the alerts page, there is a new section called the alerts assessment. If we click on it, we can see historically generated reports. Here we have an action to delete the report and to open the report. We have the report creation time, so when the report was generated, and the status, so how long it took to generate. Here, from the drop-down, you can choose the time frame to analyze, for example, from now to 30 minutes ago. Click on generate report, and the new entry is inserted, and it's running. So it means that the report is being generated. If I open a report, I want to say that EPs were changed, but the alert structure was maintained. We can see that this host transferred this file, and it's marked as suspicious. Even if it's a Microsoft download, the name is a bit strange. And it proposes a solution, but it's not very precise as of right now. It's mostly generic. So it says it provides a solution to mediate this problem. For example, this other host transferred the NER file in clear text. So it was a problem because you should encrypt your communication. Or for example, there is a suspicious file download from this other host. Here you can see some recommendations. And after that, you have other alerts group. For example, in this case, we can see DNS alerts. This host generated an invalid query and used the long DNS host name. It gives a quick explanation and a possible solution that is quite good in my opinion, because it says to check the origin IP and see if the host is infected or if there is a DNS resolver misconfiguration. It could be possible. And finally, you can have an overview of this DNS. So you can see a section for each alert type, as we had a strategy for each type of alert. In this way, we are able to precisely make reports for each alert type, and then merge the content in one report. In the future, we would also like to make this report downloadable. So I'll go back to the slides. So future developments, I mean, this approach has shown a big potential, and it could possibly disrupt SOC operation centers, reducing personnel, as it's very costly to find and to maintain qualified personnel. It's not a very precise approach as of right now. The precision is very high, but the content is still generic in some cases. It gets the problem and highlights it, but it's not direct in the solution. We also would like to reduce threat response time, as I said before, and build automated pipelines to notify if there are some problems that are happening on your network. We want to propose solutions to the problem like we are doing, but improving these responses. And we also would like to add the reasoning capabilities, because right now it's just another way to show alerts. And as I said, these reports are precise, and we have 0 to none hallucination. So hallucination is when large language models makes up an answer because he doesn't understand the question or doesn't know how to answer. This is possible because we use labeled inputs such as ntopng Alex that are correctly classified by ntop. There could be some false positive, but that's almost impossible to bring them to 0. And in my opinion, this is a better approach compared to traditional AI, as we have this model that is already pre-trained and just does the reasoning stuff. We don't need to train a model with labeled data about our domain knowledge. So we can fine tune it with additional information about our topology, but we don't need to provide the labeled data. And lastly, if you want to discuss or give some feedback or improvement, you can contact me at this email or at the end of the webinar. Thank you.
Thank you, Gabriele. I'll share my screen. Can you see my screen?
Yes, Alfredo.
Yes.
Okay. So this is Alfredo. I want to update you about, let's say, lower level technologies that we develop. So technologies that we use for packet manipulation, packet capture acceleration, so to feed our applications at high speed with packets. So first of all, I want to talk about a new tool that we developed since the beginning of this year, which is dedup. But let's start with the motivation. So from time to time, our users experience issues with duplicate packets. That means that your monitoring tool is receiving a copy of the same packet twice, for instance, when capturing from a spam port. This may depend on the switch configuration or also on misconfigurations, routing issues, congestion in your network, etc. Sometimes a duplicated packets is just a retransmission, so it is expected to see that, and you want to see that probably because you want to see if you have a retransmission. But in other cases, like in a wrong spam port configuration, this can be a problem because, for instance, if you configure your switch to monitor all the ports on the interfaces on the switch, and you monitor both ingress and egress traffic, you may end up having two copies of the same packet because a packet is entering an interface and leaving the other interface. So this is captured twice. So what happens is that you get double the same, 2 times the same packets. For instance, here we can see that we have 2 times the blue packets, 2 times the green packets, etc. As a result, if you're monitoring this data, you have, first of all, issues with resources because you're using up to double the bandwidth that you actually need to monitor the data. Your monitoring tools will use 2 times the same CPU load, memory, etc. And then you also have wrong statistics because you see that the throughput is higher than expected and you don't understand why, or you see retransmissions and you don't understand why. So they are all consequences of having duplicate packets. Or if you are dumping data to disk, you can end up using double the space that you expect to use on disk. That means translates into much lower data retention time. So for this reason, we decided to create this tool, dedup, that you can deploy inline to filter the traffic that you are monitoring and discard duplicated packets. There are appliances which are doing this, like packet brokers, usually high-end appliances which are costly, and they usually also have limited resources for this because, as I will show you, doing the duplication is expensive because it requires some buffering. So you usually, when you buy an appliance able to do the duplication, you have constraints like this can work up to, I don't know, 40 gigabit with a time window of 1000 milliseconds, usually is the maximum that you can see. But let's see how it works. So when you, this is an example of duplicated packets. And this is the, let's say, the easiest one, because here you have duplicated packets just one after the other. So in this case, the tool or the appliance that should do the duplication receives a packet, then move to the next one. Then if the next one is the same packet as the previous one, it discards the second one, and that's it. This is simple. But in other cases, you can have duplicated packets after thousands of packets, depending on, for instance, the buffering on the switch, if this is caused by the span configuration or other factors. So this means that we need to check, when we receive a packet, we need to check if there is another similar, very same packet in the past, I don't know, thousands of packets. So the tool is implementing what we call a time window. So we receive a packet, we have to check this packet, compare this packet against the past thousands of packets. So you should be able to configure a time window in milliseconds or seconds. If you consider 100 gigabit, for instance, a time window of 100 milliseconds means that you should compare this packet with up to 50 million packets per second in the window. We do this in a very optimized way using a strong hash function, a fast hash function, but this means that we have to keep track of the last, for instance, 50 million packets and compare the new packet with them. So as I said, this is a tool. This is shipped with the ntop package, and you can install it on a dedicated box with a couple of network interfaces, because this works as a transparent bridge. So you connect usually the mirror port on the switch or any traffic source to one interface on the machine running ntop, and then ntop is checking for duplicated packets and forwarding those packets to the second network interface, where you connect your ntopng, ntdisk, or any other third-party appliance. We use, of course, our PFRing zero copy drivers to do packet forwarding at high speed, up to 100 gigabit per second. This is software, so you can customize the window size. There is no hard limit. The only limit that you have is the RAM. So if you need a window of, I don't know, 5 seconds, you can just put more RAM and enlarge the window. And for instance, in order to process 10 gigabit and you want a window of 100 milliseconds, this tool is using just 200 megabytes. So with 2 gigabytes, for instance, you can handle 100 gigabit per second. Okay, now let's move to the PFRing itself, and let's see what we did during the last months, the new features about supported network adapters and SmartNICs. So you probably know that our PFRing framework, which is the framework, that the drivers that we use for capturing packets at high speed, support many adapters. And some of them, for instance, all the Intel adapters and NVIDIA Mellanox adapters are supported by our PFRing zero copy drivers. Also, specialized FPGA adapters like Napatech or Silicon Fiberblade, they are supported by our PFRing zero copy drivers. And for instance, during the last webinar that we had last year, we have seen that we can use our PFRing zero copy drivers to accelerate the packet capture. And in case we want to accelerate an application like an IDS or an IPS, we can also do layer 7 filtering, because the IDS and IPS systems are really CPU bound, so we want to reduce as much as possible the input. So we want to discard traffic which is meaningless for them. So we can use pfring zero copy to capture the traffic at high speed, and pfring ft, which is part of pfring, to filter out layer 7 traffic which is meaningless, like, I don't know, compressed traffic, Netflix, YouTube, etc. And you can run these on top of any adapter like Intel or NVIDIA Mellanox. And then we've seen that we implemented what we call the on-demand IDS. The idea is that an IDS, again, is CPU intensive, not able to cope with 100 gigabit per second full rate. So we wanted to further accelerate them, not just filtering out unwanted traffic like multimedia traffic. So the idea, using the NVIDIA ConnectX adapter, which are able to duplicate the traffic, send the same traffic to multiple applications at the same time, even using zero copy drivers, was to capture all the traffic with nprop CentOS and analyze the flow information extracted by CentOS using ntopng, and at the same time just discard all the traffic to the IDS. As soon as ntopng detects that there is some misbehaving host, ntopng can push a rule, a filtering rule to the adapter in hardware. And NVIDIA Mellanox is really good with this because it supports many rules, like 64,000 in ConnectX 5. And only at this point, the traffic for that specific host is forwarded to the IDS or IPS for matching signatures, for instance, to detect a malware or similar. So we are, let's say, moving because we already implemented drivers for accelerating the packet capture. We are trying to take advantage of all the offloads available in the adapters to further accelerate the traffic analysis activity. So for this reason, we moved to another use case, which is traffic policing. In fact, we have CentOS, our 100 gigabit NetFlow exporter, which is also able to bridge the traffic and act as a policer. This means that CentOS is able to bridge traffic at 100 gigabit, discarding specific layer 7 protocols, for instance, to block traffic based on the application. And this is, of course, stateful. So CentOS is keeping track of all the network communications, and packet by packet is processing the packet and forwarding or discarding the packet. So we wanted to leverage on SmartNICs to accelerate this. And Napatech is helping with this. In fact, Napatech adapters, SmartNICs, implement what they call the flow manager, which is a flow table in hardware. And these can keep track of all the flows, all the network communications, up to 140 million communications direct in the adapter. And is really fast with this, can learn more than 1 million flows per second. So this means 1 million new flows per second, up to 140, of course, using a single CPU core. If you use multiple cores, it can do much better, so even 3 million flows per second. So we integrated this with nprop CentOS. So what we do is we capture the traffic through the adapter using nprop CentOS. As soon as we detect the layer 7 protocol, for instance, we say this communication is about Netflix, we offload this flow to the adapter. This means that the adapter will forward or discard according to the verdict that CentOS is emitting all future packets for the specific flow in hardware. So the Napatech adapter is implementing the flow table and the traffic forwarding. This means that, in essence, with a couple of cores, you can handle 100 gigabit per second. work in progress. Besides working with what we have seen until now, we are also experimenting with the NVIDIA Bluefield adapters, which are system on chips. So they include inside the same adapter connect-text interfaces and a CPU with 64 ARM cores that can be programmed using the Docker SDK. So what we did so far is we ported NDPI in the adapter, so it's currently working. We are investigating to support also the connection tracking in the adapter to implement something similar to what we did with Napatech. So if you want to use the technologies that we have seen, you can find ndedup, so traffic deduplication tool inside the ntop package from 3.7 in the 3.7 version of the package, and the Napatech flow manager, so the ability to offload the flow table in hardware with CentOS is already available in the latest development version 1.21, and of course in pfRing. Also, of course, the ability to deploy an on-demand IDS using the NVIDIA connect-text is already there since the last stable. It was last summer, and now we are working on the NVIDIA Bluefield. So probably for the next webinar we will come with the implementation. You can run it. Okay, thank you. Now I will let Matteo talk about the new features in ntopng.
Hi, hello, can you hear me?
Yes.
Okay, great. Let me share these slides. Okay, you should be able to see slides, right? Okay, great. Hello, everyone. So now let's talk about ntopng. We have some news regarding ntopng. Mainly, performance is focused. We did quite a lot of announcement regarding performances in ntopng. But before talking about performances, let's talk about SMP and reports. Lastly, in the last versions of ntopng, so 5.6, 6.0, we talked a lot about alerts, cybersecurity, and even user interface. If you remember, we developed the new dashboard, we changed the alert page, and so on. So we did quite a lot of things regarding, like I said, cybersecurity and user experience. In this version, instead, we tried to go back to the origin and mainly develop towards network analysis and device monitoring. So what we wanted to answer in this latest version was regarding who did the most traffic. Imagine that you have many exporters in your network and you want to know, for instance, if one of those exporters, if one of the interfaces of your exporters is congested. For congested, I mean the bandwidth usage is up to 90%, 95%. We tried to develop something regarding this point, and we wanted to answer this question. So we developed this usage, we call it the usage, to understand if some of our interfaces of the devices we have in the network are congested. For congestion, we mean that, like I said, the bandwidth is filled over 75%. Combining the previous features we developed in ntopng, so for instance, the historical page, the time series, now it is possible to understand who, for example, congested in the network. which were the culprit of the congestion. So what we can do now is by using this usage page, it is possible to jump, see if some interface is congested, then check the time series, like you can see in this screenshot, and from zooming in the congested period, we can jump to the historical flows. If that device congested is an exporter, then we can see from the historical flows which were the hosts that congested the network, which were the flows, and possibly stop those. Other than that, obviously, what we need is the possibility to be notified whenever this kind of situation happens. So whenever, for instance, the usage of an interface is up to, I don't know, 70%, 75%, even 75, it is pretty critical usage. So what we can do is by using the developed network usage page, the network rules page we developed in the 6.0 version, we can trigger alerts with a custom threshold by saying, okay, whenever we see, I don't know, the usage higher than 70%, we can trigger alerts and send those alerts to custom endpoints. Regarding the network rules, we do not added just this feature, but we added many more rules, configurable rules. For instance, for exporters, for SMP, we added a couple of new time series regarding SMP. And in this way, we can monitor all the devices we have in the network, if everything is working fine, or if there is some kind of issue regarding the traffic and the usage. Before jumping to the next point, so the reports, I want to show you a quick demo about this new feature. Let me share the screen. Okay, you should be able to see the browser. Can you see ntopng now?
Yes.
Okay, thanks, Alfredo. Regarding the usage, what we can find the usage from the SMP page. So for instance, here, as you can see, I have an ntopng instance with quite a few interfaces currently monitoring. And currently, I have just one exporter. What we can do is by jumping to the SMP page, we can see all the devices configured. And if you remember, the exporters is the exporter sending the data to ntopng is the 106, the 2.106. This is the MyCrotic. This is exporting currently the flows towards ntopng. And what we can see is that here we have the lens to directly connect to the historical flows. So if you click on the lens, as you can see all the flows exported by this device. Let's go back to SMP. And here we have the usage tab. Now, currently we do not have congestion interfaces, so everything seems working fine. In fact, as you can see, the congestion rate is 0% in pretty much all the interfaces of the MyCrotic. And what we can see here, for instance, instead of, if we had a problem with one of these interfaces, what we could do is the following. For instance, let's imagine that we have a problem with other two. We can directly jump to the interface, to the time series of this interface. Now, as you can see, everything is fine because it is 0%. And in this, for this device, it is quite good that is 0%. Let's take a look instead at another device with some congestion. Let's jump back to the home, to the SMP home, and then let's jump to the usage. From here, instead, we can see the same page, but filtered out without filters. So we can see, for instance, all the devices we have and interfaces we have. We can see that even here, everything works fine in the last 30 minutes. We can even put last week. And everything works fine. No congestion rate, so all devices are good. But what we can see, for instance, is that the devil is the one with the most average. So let's take a look at the device. Let's zoom in these last few hours. And as you can see, for instance, the uplink and downlink usage, so in and out usage, is an average of 2.3. From here, if we had a problem, and if this was an exporter, so here it is not an exporter, but what I can do is, for instance, for the 2.106, we could zoom in a specific time frame and then jump to the historical flows. In this way, we could see who caused the congestion, of the interface. Regarding the rules, instead, we can access the SMP rules directly again from the SMP page, clicking rules. And from here, we can configure all the rules we want. By clicking the plus, we can add new rules. For instance, let's put the rules for the usage for the macrotic. You can put, you can check all the interfaces with the star or a specific interface. The other one, for example, for the usage. So let's change from bytes to usage, percentage, and the threshold is, I don't know, 60%. 60% seems a good threshold. From here on, whenever we see a usage higher than 60%, an alert is going to be triggered. In this way, we can monitor the interface we are interested in. So let's just jump back to the slides. Regarding reports, I was saying in the last webinar, so in October, October, I think it was, we promised that we are going to develop the possibility to customize reports, and we kept our promise. In fact, now in ntopng, it is possible to create custom reports and edit those reports with widget we have. Obviously, those widgets are predefined widget. And in this way, you can create your own report with your own information you are interested in. To create a report, it is pretty simple. You just need to click this icon on the upper right part of the screen, the plus. And then after creating a new report, you can edit the report by clicking the yellow edit icon. And after that, you can add or remove, as you can see here, add or remove widget and so on. Now, regarding performances, we have quite a good update. We did quite a good performances update, and we were able to more or less halve the memory usage of ntopng. As you can see, for instance, in the first screenshot, this one, we were able to lower the RAM usage from half a gigabyte to 200 megabyte. And here, this is a network with 10 to 15 megabit per second. Here, instead, in this other screenshot, the lower one, this is a pretty huge network with 1 gigabit up and down per second. And as you can see, we lowered the memory usage from a peak of close to 4 gigabit, if not higher than 4 gigabit, to a usage of 2 gigabit, pretty stable. Other than enhancing the RAM usage and performances of ntopng, we even added coroutines to flow exporters, just like for SMP. In this way, we are able to pull and gather a lot more information about flow exporter in a better way. And even thanks to that, we decided to possibly pull in a per minute basis SMP for exporters. So if you have an exporter and you have SMP enabled, we can pull information about that exporter by using SMP in a per minute basis. In this way, if you have problems with your exporters, you can find those problems as fast as possible. Here it is an example. As you can see, it is a per minute time series. Thanks everyone for listening. This is everything regarding ntopng.